Guys, starting.
Good morning, everyone. Welcome to the day two of CEM WHR virtual conference, the second edition of Waste Heat Recovery virtual conference that we are doing for the cement industry. Because of the obvious reason that it's because of the COVID scenario and the pandemic situation in the country that we are doing this virtual. And day one, yesterday we inaugurated the event, and day one we received, we invited a lot of wonderful speakers to join us, where we saw a wonderful panel discussion where Mr. Raju Goel joined us from Ultratech Cement, Ms. VM Murthy joined us from Rain Cements. After that, we saw some technical presentations where we witnessed Mr. Goel sharing about CO2 reductions and emissions, and we saw Mr. Anjana sharing his best practices, and Mr. Joseph Johnson, head of WHRS from ACC, sharing their technological presentation on how they are looking forward and what are the steps that they are taking within the organization. After that, we saw a technical presentation on the barriers from Mr. VM Murthy, and we witnessed the technology presentation where we got to know what are the latest technologies and what is the future from Mr. Amit Narkede from Thyssen Group, Dr. Sham Digge from Aquasource, Dr. Hans Conrads from Promicon, and Mr. Nilesh Jadhav from Sitson. Before we start day two, I would like to thank our associate sponsors, Ecosource Technologies Corporation, Promicon, and Sitson India. Today, what we are going to talk about is the first session that we are going to start with is about sustainable development through waste heat recovery. We heard about this yesterday from few of the gentlemen who joined us, where they spoke about the environmental angle and the sustainability roadmap on a very briefed way. Today, we are digging it a little deep. So we were supposed to join by Dr. Subrato Chaudhary, but his direct cousin expired due to COVID. So he won't be joining us due to this unavoidable reason. We have Mr. Ashok Dembla, the Managing Director for Humboldt Vidag India. Good morning, Mr. Dembla.
Good morning.
We are wonderful to have you on board. Moving forward, before we start with the highlight session where we are waiting for Mr. Roy Chaudhary also to join us, I would like to give a very quick brief from the reason why Mission Energy Foundation initiated this subject and moving towards researching more about the subject. As per the market reports, as per the statistics, as per the understanding, what we have seen that the Indian cement industry is very keen to adopt waste heat recovery systems in a big way. The technical specialization within the Indian cement industry is advanced. The plant operating team can overcome the technical barriers analyzed, be it any. The major deterrent in faster adoption of waste heat recovery systems has been the financial barrier, as per the reports or the consulting firm suggests. The potential for WHRB in immense in Indian cements industry is huge and high. With its objective to promote WHR installations in India, We Mission Energy Foundation brings you the second annual, where what we are trying to do in the virtual conference is to do a virtual conference where we are discussing about major subjects to promote waste heat recovery boiler implementation in the Indian cement industry. Our agenda is to encourage utilities that utilizes the waste heat available to generate power and thereby reduce operation cost. Our agenda is to bring awareness among industry on suitable technologies may be considered for implementation of waste heat recovery in existing and future cement plants. Parallelly, we are running a virtual expo where we are joined by Aquasource Technologies, Promicon, and Citizen India. And by the end of the day, we are running an awards, which over the years, Mission Energy have honored hundreds of innovative developments and solutions for excellence and sustainability among the utilities, small or large, who have demonstrated their efforts in generation of clean energy as a gesture from our side. Today, when we are talking about the sustainable development, We have a thought that the efficient and sustainable utilization of energy is a crucial aspect to reduce global greenhouse gas emissions in such quantity to reach the goals of Paris Climate Agreement, a very important agreement that's there. We are looking at from past many years, wherein the countries are taking part towards a green future. Hereby, waste heat is an unconventional energy source which has a high recovery potential throughout different countries. Today we are talking about India and cements, but throughout countries it has been proven in a way that it is absolutely an unconventional one. In last decades, we saw that there are different technologies which have been proposed to recover the aforementioned thermal energy, electricity generation, direct utilization, or thermal water treatment system, just to name a few. Researchers mostly focused on theoretical or experimental studies dealing with thermodynamic and constructional aspects. However, sustainable systems have to cover a broad range of additional characteristics such as environmental, economic, and social aspect. This line, the reason why we mentioned this line is to be very clear. When we say sustainable development, we are not only focusing on the environment aspect, but the economic aspect and social aspect. Now, I would be more than happy to request Mr. Dembla to please share your thoughts, the opening thoughts, before we initiate the discussion and receive Q&As from the audience. That when we said sustainable development through WHR, what are your thoughts on that? Over to you, Mr. Dembla.
Yeah, thank you, Mr. Akshay Mishra. I'm thankful to Mission Energy for giving me a chance to speak on WHR and sustainable aspects of that. You know, cement industry consumes around 8% of carbon footprints are given by the cement industry, and human life is already on the danger because of carbon footprint from various industries as well as from other sectors like transport and similar other factors like food industry and all. So almost one third of the carbon footprint is coming from industrial production, and cement is a energy intensive process where thermal energy is consumed as well as the power is also consumed heavily. So thermal energy directly contributes to a lot of carbon dioxide, and we burn also fuel to provide the calcination of the limestone, as well as we generate say carbon dioxide because of fuel burning. So apart from this, there has been power consumption comes from mostly from thermal power plants. So that is also indirectly contributing to carbon footprints. And many plants have CPP, captive power plants based on the coal or fossil fuel. That also contributes a lot of carbon dioxide, carbon footprints. So all this is one of the important aspect for reducing the carbon footprints. So when there was danger to human life, so there were discussions how to control it. So many cement industries came out of their own to reduce the carbon footprint. Of course, carbon bonds were also there to give attraction to the industry. But mainly, I think because of high danger on the environment, many industries came of their own. Like, Dalmia Cement declared that they will reduce the carbon footprints by this much percentage by 2030, and by 2050 they want to be carbon neutral. Similarly, Lafarge Holcim, if you see, they also came with a big planning to reduce the carbon footprint of their own. And yesterday we listened to CTO from Ultratech. He also mentioned that they have a fixed plan to reduce the carbon footprints by one third or so by 2032. So you can see the gravity of the situation, that carbon footprint has to be reduced. So what are the methods to come to carbon reduction in carbon footprint, as well as to come to carbon neutral situation? So there are some soft methods to reduce the carbon footprints. Soft methods include optimization of the process. You have always chance to reduce the thermal energy consumption in the cement process. You have always a chance to reduce the power consumption through technological developments in the cement industry. Those are steps which are not too larger steps, but smaller steps. Then there was another larger step towards the waste material utilization, that is alternate fuel instead of fossil fuel. So industry went of their own to use alternate fuel, although the government is not ready to provide the processed fuel at a reasonable cost. But industry took a lot of efforts to put the machinery, and now there are a large number of efforts to use municipal waste. So of course cement industry is trying to take the support from the government in order to mobilize the municipal waste. But I am sure that within span of 5 years some schemes will come, and industry will get at least the alternate fuel at 60 or 70% of the cost of fossil fuel. That will be the right time, because they also need to invest for the alternate fuel on machinery and use it. And machinery suppliers are also ready to provide various technologies. Now, next aspect is about the cogeneration, which is WHR, use of WHR, waste heat utilization. This is a big step where we can, power wise, we can use almost, earlier we used to say 1/3 of the power can be used if the cement industry is using, say, 80 kilowatt hour or 72 kilowatt hour, depending upon what technology they are using and what limestone they are using. But 1/3 could be generated through WHR. But recently now, up to pyro, you can use almost, you can generate up to 70 to 80% of the power up to pyro by waste heat recovery through very innovative methods. Some of the methods we learned yesterday, and in the cooler we have now mid-air tapping. We can use even HAG, hot gas generator, to increase the temperature of the cooler mid-air. So all this has led to almost meeting the requirement up to pyro process, maybe 80%. So those steps are very important. We have the history from Japan and then China, that they made almost compulsory to use WHR, waste heat recovery systems, in order to put up the cement plants. And fortunately now Indian government is also giving the approvals only for cement plants when they are putting the WHR also. So that is a welcome step, because as soon as you put the WHR system in place, you are using only say thermal energy for the purpose of calcination, as well as for coal burning. Up to 80% you can use, efficiency goes more than 80-85% instead of 55 or 58%. Then that is a very welcome step. Now, apart from WHR, say we are also focusing on green energy, which is also a welcome step for the sustainable development, carbon footprint. Now, what is green energy? That is mainly solar energy is very, very important for India. Wherever cement plants are located, we have a lot of space there to put the solar panels, because solar energy requires a lot of land. And fortunately, the cement plants are located in remote areas. Land is relatively less problem, although it is becoming costly day by day. But still, you can have land and you can have solar panels installed properly, and maybe you are able to substitute some percentage of energy by solar energy. So that is also going on. Many plants have taken steps, and fortunately, the rate of installation of solar energy has also come down over last 10 years. We were talking about 12 crore or 15 crore per megawatt. Today we are talking about 4 to 5 crore per megawatt for solar energy. So then comes the wind energy. We have many coastal areas where wind energy can be produced, and when you go through the Gujarat or coastal areas, you see a lot of wind energy turbines have been put for generation of energy. So that is also a welcome step towards sustainable development. So apart from that, when we have to come to another technology, which is called the disruption of technology. That is, we have to come to carbon capture techniques, capture technologies. So already a lot of discussion is taking place on carbon capture technology. At present, we are at pilot scale in many overseas countries, as well as Dalmia has also taken a step to put carbon capture and use carbon for the byproducts used for various industries. So that means they will capture the carbon and use make some materials which are day-to-day use for the product. But more than that, carbon capture and will require a lot of investment at the moment, if we see, and it has to come from pilot scale to the industrial scale at a viable capital investment. So that will be the final step towards when we talk about carbon neutral. So carbon capture technology will be the final step. Say we can reduce one third or maybe 50% carbon generation through these techniques. That is green energy and process optimization, say oxy-fuel and various technologies. But ultimately, then we have to resort to some technology like carbon capture. Whatever carbon footprints are left, carbon dioxide, so those have to be captured and used alternatively, in some production of some other things. So this is the holistic view of the sustainable development, out of which we are now focusing on WHR. What is the function of WHR? In WHR, I think we are clear that the routine way of working was 20 years back, if I see, that we were wasting a lot of energy out of total. Suppose we are consuming, say, in typical 5-stage preheater, we are consuming around 710 or 720 kilocalorie, and in 6 stage we are consuming around 700 or 695 kilocalorie per kg of clinker. So out of which only 55 to 58% of this thermal energy is really used in the process. That means calcination part of it and burning part of it. But rest of the energy was getting wasted, and some of the energy it is very difficult to capture. Like you have radiation losses from the kiln and preheater. You have some radiation loss in cooler, small amount, maybe 5 kilocalorie. You have some energy gone with the clinker, because clinker temperature is also there. But when it comes to preheater exit and cooler exit, there a lot of energy is there, and part of this is used definitely for drying of the raw materials. We have to dry raw materials as well as coal. Yesterday also we learned about it. So depending upon the moisture content in the raw material and coal, we have to use this energy. So now the focus is that how to use minimum energy for drying. Suppose we are working in dry areas like Andhra Pradesh, we are working in Tamil Nadu, or we are working in Gujarat, or some areas where rains are not there, and moisture in limestone is only 2 to 4%. Then you can always first generate the power out of the high temperature gases, and when we get out of turbine 160 to 180 degrees centigrade temperature gases, those we can use for drying, and technologies are available, say vertical mill, roller press, because moisture is not so high. You don't want quality of heat in such cases. In case of say cooler gases, most of the time cooler gases are available, and earlier the concept was to have exit gas from the cooler, which was around 300 degrees centigrade or 240 degrees centigrade. Now we have mid-air tapping. We don't want to disturb the process. That means null point. Yesterday also process people were there. They were explaining that null point should not be disturbed in the cooler, so that we have proper heat available for the pyro processing. But after the null point, you can always draw the heat, draw the gases, which may be in the cooler. Normally, you put 2 NMQ per kg of clinker, and out of which the process requires around zero point 0.7 to 0.8 NMQ per kg of clinker. Rest of the gases are available. So if we can have a technique to draw these gases at high temperature, high quality heat, and generate the steam out of it, and then use it for power generation. So that is also a big step towards power generation. So cooler gases are almost contributing to 60% of WHR, sometimes 50 to 60%. So this way we are producing, if a pyro process uses, nowadays we are talking up to pyro process, the electrical energy consumption should be less than 45. So out of 45, if you can generate 35 through WHR, that is a very welcome step. So fortunately, over the last 20 years, there are very good developments. Indigenously, if you see Thermax and say Thyssen Group and now ISJAC, they have developed the boilers tuning to this WHR, because this type of power generation requires special attention. Gases have a lot of dust from the preheater side, and cooler dust is also very abrasive. So you cannot have normal boilers. So over the last 20 years, I think it is commendable that whatever development has been done by Thermax or Thyssen Group or other Indian companies to come with a boiler which is suitable for WHR. So earlier we were depending upon foreign companies. First project of WHR came in Rasi Cement, which was double the cost of at least 1.8 times the cost of today's installation. And it came with the aid from Japan, and that was a success story in 2003 or 2002. First plant, Rasi Cement, came. So after that, I think Indian entrepreneurs, they put a lot of efforts to see that how this technology can be developed within the country, and we have very good way of generating the power with less problems related to corrosion, erosion, and operation. And fortunately, we are the people who can operate our cement plants relatively consistent now. More and more reliability is getting the focus now. In Corona time, there was no time for too much fluctuations and too much disturbances, because manpower has to be reduced and automation has to be improved. So I will see that more trend will come towards optimize production, not the maximize production. The 10 years back, the focus was how to maximize and then reduce, maximize, reduce. So that was also changing the WHR, sometimes very high, sometimes low. So these fluctuations will have to be brought to a minimum level. We have to operate the plant at say very rated production through digital means, automations, and take the waste gases from these sources as a reliable way. Still, we have to work out on rainy season, how to cope up for the rainy season in India for 3 months, where temperature goes, where the raw materials have high moisture, and we need this energy, say, for the drying of the raw material. For 3 months, I think hot gas generator makes a lot of sense. It requires very less investment. Yesterday also we heard, and maybe that is one alternative. But what to use in hot gas generator? One of the speaker, I think, talked about the bio material to be used, or the can we use biomaterial for the hot gas generator during rainy season, and bring the temperature or the heat available for WHR same, so that there is no problem in ultimately when you operate on WHR, you get less sanction of the power from the government. You plan your whole plant that out of 80 kilowatt hour per ton, I will use 30 from the cogeneration and 50 I will take the sanction from the government, or whatever the values are coming. And when in rainy season this balance is not there, then there is a problem. So to solve that problem, I think hot gas installation to cope up for 3-4 months of rainy season may be a good alternative. So I think with these views, I will put up that sustainable development relates to carbon footprint. Carbon footprint directly relates to human life. So it should not be treated as a non-serious subject. So we have to work on it, and I think WHR is one good step or a big step towards reducing the carbon footprint. So we have to go ahead with 100% rather in coming 10 years. The WHR in old plants as well as new plants. That is the only way I can see for India.
That's actually to the point and a wonderful opening to the discussion. Before we put the next point, I would request all the attendees to please write their question in the chat area so that we can take it to Mr. Demla, and or they can raise their hand if they want to join us. Since it's a chat session going, so we'll be more than happy to have your thoughts. If you want to ask anything or if you want to share anything, like how you are maintaining your social sustainability roadmap when we talk about this. I have a point where when you mentioned about green energy. I
Yeah.
just want to understand what are your thoughts when we say it's going. So, do you think WHR and the green energy can go hand in hand when the biggest challenge that industry faces the current scenario is one can be the rising energy prices, one can be an operational cost, one can be the increased cost of power, one can be the depleting energy sources. So, do you think at this point of time when we have so many challenges, and I understand that green energy is not cheap at the moment, we are moving towards a vision. We are setting up a lot of manufacturing units just to cut down the
Mm.
cost on the operation side and on the manufacturing side. Do you think how soon we can see this that WHR can effectively go hand in hand, because these are the major barriers that the industry is facing right now?
In WHR, at present, the total installation cost is around 8 to 10 crore per megawatt, which is already down by 20-25% from the level of 10 years back. So this has come down. Now operational cost, if you see the cost of financing also, otherwise operational cost is only 50-60 paisa per ton. So which is much less than the thermal energy, which is costing around 6 rupees from the thermal power plants or from government, and maybe 4 rupees for CPP. So there is a net saving of 4 rupees per kilowatt hour ton. Saving is very high. Now there are technologies that we can use it on a consistent basis, and how to maintain it. I think yesterday's lecture from Lafarge Olsen was very interesting. How to maintain your plant, WHR plant, and what technology we should select. And then there was a paper from Thiessen also, that what steps they have taken to make it more reliable. So all these steps are saving rather than spending. They are indirectly saving. WHR is saving the electrical energy cost, generation cost and all. So out of say 80 kilowatt hour per ton, if say 30 kilowatt hour per ton can be generated at 50 paisa operating cost, say net saving of 4 rupees per kilowatt hour ton. So you have a direct saving of 120 rupees per ton of cement. So that is the way you should see. So that is a good saving WHR. Now coming to solar energy, that is also now has become very reasonable installation cost. You have to spend only 5 to 6 crore per megawatt, and you used to spend 15 crore at one time. Now Chinese have come with a lot of technology, and cost of installation and machinery has come down. So that is also a big saving. Although the generation of solar energy is not very much, maybe 8-10 kilowatt hour per ton you can generate by installing solar panels and all. And of course, the main issue with solar energy is you cannot store it at the moment. But people are working on storing the energy. Now at present, during, except the rainy season, all the seasons you can get solar energy and use it. So that is also a good saving, 8 to 10 kilowatt hour per ton. And installation cost is not very high. Operating cost is already low. Land is available in remote areas where cement plants are located. So it is also an ideal case. Same is with wind energy. Wind energy, but it has a limitation that you should have coastal area and high velocity of the wind to produce it. So that is also, in terms of economics, it also works better. But when we come to carbon neutral, the main technology, say, disruption has to come in CCU, that is carbon capture technology, which at present is very costly. So, but people are working on it, and it may take maybe 10 years or 15 years. R&D is going on, and it has to come to reasonable level. But that situation will come only at the end, after 2030 or so, that carbon capture will be required. In a in a very big way. Now coming to thermal energy side, say thermal energy reduction side, alternate fuel. There, you can use agriculture waste, you can use, say, other materials like coming from industry. Say, there, I think investment, they are investing, but of their own. But now, when it comes to municipal waste use or plastic use, there a lot of efforts are required to collect, store, and prepare for the cement industry. So at present, if there is no support from government or the producer of waste, then there is a problem that the cost may be high. So their breakthrough has to come, and it has to be effort from the producer as well as the cement producer as well as the waste producer to come together and work on it. And support of government in financing shall also be required for to prepare this waste, and then it may become a reality in coming 5 10 years. Already people are working on municipal waste. A lot of efforts are being put in.
With that, next question that we have seen, and we have seen in many forums about this question, that do you think the regulatory current scenario of the regulatory or the regulations is supporting the cause? Because when we talk about 6 years, 10 years down the line, the regulatory at the present has to be very strong enough supporting the Indian government or Indian cements industry. So, what are your thoughts on the regulatory side?
On regulatory side, I think there are some cases which are very, very good cases. Like we have case in Indore city, we have Coimbatore example, where local DMs, they made it compulsory to properly segregate the waste and then bring it to the central place. And then Goa was another case where government interfered and spent some money on preparation of the waste. So already from the government side, efforts are at not at consistent level, but at individual level. Some cities like Indore is performing very well in collection of waste and then preparing it. So this has double advantage. One is city is clean. Second is you are making the people aware of the how to treat the waste and give it to the people. And there are agencies like collection of plastics. People are ready to pay. Hotels are ready to pay for their waste. So hotel industry is also giving the waste in a proper form and paying also to the because they are producing the waste. So now house owners, they are ready to pay. We are also paying 100 rupees or 200 rupees per month for collection of the waste. Now education is required. Municipalities have to do little more work to collect this waste in a proper manner and bring it to the right places. And at present the focus is to produce fertilizer, but ultimately it has to go in the production of the energy. That is the right way, and efforts are already on. It is a matter of putting the focus, more focus for the regulatory authorities to come to a formula. And whenever these things happen, storage and handling and preparation will require some initial investment, and government has to support it. There is no doubt. And Goa government supported and provided the waste to ACC Wadi and Ultratech plants at some cost. So, like that, examples have to be set by other governments also to collect the waste. Like you see the hue and cry near Delhi during crop cutting, how much they burn it. And now there is no other way but government has to come and get it collected, and partially they may be able to collect the fees, from citizen. Otherwise, if if the producer of the waste is not giving money, indirectly all taxpayer are giving money. So I mean, taxpayer, instead of there is another method to increase the taxpayers bracket to larger one, so that they are paying directly or indirectly the taxes every citizen is paying, and it is used in the right direction for these type of things.
That's a wonderful point to put. I have we have received few questions, but I'm sure that will be covered during your presentation. So, final two questions that I want to know from your side. One is, what are the future trends according to you? Because you are an expert, you not only focus on your study, do not only focus on India but the entire world. But we'll stick to India for a while. So, what are the future trends? And then I would request if we can have a concluding note on this sustainable development through WHR from your side.
Worldwide, the trend is that these WHR is a part of the, I gave the example of Japan and China. So Japan took the first lead to focus on WHR, and they made it compulsory for all cement plants to have WHR. China also made it, or technology, they made it cheaper by producing within their own country. Now all the plants have WHR. So in India, same trend is now coming, and many plants have been put. And I feel in coming 10 to 15 years, every plant will have to have a WHR system in place, and preferably through local technology to reduce the cost. So that is also very, very important, capital investment and all. Regarding waste, alternate fuel, trend is same in Europe. This activity of collection of waste and putting burden on the producer of the waste, and then providing to cement plant treated waste. So that has taken place. Maybe that started 40 years back, and today it is very stable. In 1985, I went to Europe, and the trend started already. So in India, it started little late. At present, on an average, we are using 7 to 8% of the, I think 7% alternative fuels. And whereas in Netherlands, 100% waste is used. In Germany, 80% waste is used in the cement plants. Cement plant is a good place where alternate fuels can be used almost 100%. Austria, it has been used. Fortunately, technology developers like us and other Policious, KHD, FLS, they have good technology to use these alternate fuels up to 100% in the kiln as well as in calciner. So technologies are available already. Now there are some questions on cost of the technology. In my opinion, in India, the cost of technology is also not very high. And for industrial waste, like agriculture waste, and other waste, coconut waste or some soya or these things, people have developed their own technology also in the plant. So it is not a big technology. So they have used, so things are moving. But when it comes to high end technology like combustion chamber, rotary, rotor dryer without much processing of the waste, their cement industry has to spend, and they are trying to see that how capital investment can be justified through saving in the use of alternate fuel. So at present, a lot of balance is to be done between cost of the waste which they are receiving. For example, municipal waste. If they are putting a lot of money on transportation, and the fossil fuel cost is also similar, and they have to then put capital investment to process it. So if the total cost is more than the fossil fuel cost, definitely they will not go. Everything works on economics. So I think these economics have to be set right, and trend is worldwide like this, and this will come in India also.
That's a wonderful note to end and technically to start the day two of the conference. And on that note, we can summarize this saying that waste heat actually ranges from industry to industry, despite whatever the industry it is. So the recovery of this wasted energy can play a significant role in reducing the entire environmental footprint in the manufacturing or the cement sector, where we can actually see if the things moves in a way that we are looking at, the future practices will be sustainable, where we are looking at the sustainable development. On that note, I would like to thank Mr. Ashok Dembla, who joined us for the start of the session, and we are looking forward to your presentation in the right after the networking break, along with the CEO of My Home Industries joining us for the technical presentation as well. Till then, we are taking a very short break, and we'll be back again at 11:30 with further technical presentations from Mr. Demla and Mr. Roy Chaudhary and other senior dignitaries from the industry and solution side. Thank you so much by then, and we'll be back again at 11:30.
Thank you, Akshay.